Hello all. Now I will be discussing another important model, linear programming problem solving using Simplex method. So here in the Simplex method, function is given as minimization and constraints which are less than or equal to. So let us start solving this particular problem using the Simplex method. So before that, we have to convert the given function into the standard form. So the minimization function given minimization of z, that is equals to 10x1 plus x2 plus 2x3. So subject to the constraints given 2x1 plus x2 minus 2x3 less than or equal to 10, 4x1 plus x2 plus x3 less than or equal to 20, where x1, x2, x3 is greater than or equal to 0. So we have to convert the constraints into the standard form by adding a slack variable. So here the first constraint is 2x1 plus x2 minus 2x3. So the slack variable I am adding as s1, which is equals to 10. In the same way, we will be adding another slack variable to the second constraint plus x3 plus s2 is equals to 20. So in the Simplex method, we have to draw the iteration table. With the help of iteration table, we can solve the Simplex method using the iteration table. And here if we observe, in the minimization function, x1 variables, these are all the coefficients of the minimization function. So in the iteration table, so what I am doing, so this is the coefficient Cj, okay, Cj, and here this is the coefficient of basic variables, whatever the basic variables we are taking, so we have to include there. Here the coefficients of the z function, here what he has given, 10x1 plus x2 plus 2x3, and we have added two slack variables. So here what I will be doing is 10 coefficients I am taking, 1, nothing is there means 1. For x3 here we have, see, for x3 we have here 2. So, and for slack variables nothing is there, so coefficient will be 0, 0, and this column will be considered solution and ratio. So these are all the basic variables and these are all the coefficients. So x1 is a basic variable, x2 is a basic variable, x3 is a basic variable, slack variable is a basic variable, slack 2 variable is also the basic variable. So here in the iteration table, so we will be noting down the basic variables. So how many basic variables are there? x1, x2, x3, and we have two slack variables, that is s1 and s2. By taking the constraints, so the first constraint and the second constraint, this is constraint 1 and this is the constraint 2. So here the basic variables that we have introduced. So for the first constraint it will be s1, s2. For s1 the coefficient is 0. So I am writing here the coefficient of, this is the coefficient of the basic variable. So basic variable, that is slack, for slack variable the coefficient is 0, 0. And here the basic variable for x1 is 2, 1, minus 2, 1, as s2 is not there, so we are considering it as 0. And here for s2 also 4, 1, 1, 0, 1. And here in the solution, what do we have here? 10 and 20. So I am writing here 10 and 20. Now this is the first table, first iteration table. So we have to find out Zj and Cj minus Zj. So Zj, how to calculate, how to find out Zj. So 0 into 2 plus 0 into 4. You will get 0. So here first we will calculate Cj minus Zj. Cj 0 into 2 plus 0 into 4 will become 0. As here we have zeros, so in this column all the values will get zeros. 10 into 0 is 0, plus 20 into 0 is 0. So Zj, Cj minus Zj. Cj minus Zj we got zeros, and Zj 0 minus 10. Here Zj is 0 into 2 plus 0 into 4, so Cj minus Zj in the second step. So 10 minus 0, 10 minus 0, which is 10. 1 minus 0, which is 1. 2 minus 0 is 2. 0 minus 0 is 0, and this 0. So here we don't have, as all the values are positive. But here the function given is minimization function. So we can convert all the Zj values into the negative values. So here Here also we can make a note, or directly here we can take the negative values, or here. So I am placing it here. So now here if we observe the maximum value in the Cj minus Zj row, the maximum value is identified in this particular curve. So I am identifying this particular curve. I am marking like this. In this one, so maximum, here we can select here 10 by 20. So in that one, whichever is the positive that we have to select. The solution, whichever is the minimum in the solution, whichever is the minimum, that we will be selecting. So here I am selecting this 10. So this particular row I am marking this one. Now here we can identify a intersection point, that is a 2, which can be considered as pivot point. Now as Cj minus Zj, still we have negative values. It should be equal to 0 or greater than equal to 0, then only we will reach the feasible solution. So still, as we have not reached the feasible solution, so we have to move to the next iteration. So here this particular intersection, wherever the intersection pivot point is there, so here S1 leaves and X1 enters into the place, in this particular place, and this is considered as pivot point. And whenever we observe this pivot point, all these values should be divided by that particular pivot point. So here in the second iteration table, we will have the second iteration table. In the second iteration table, again the same format, that is CBI, Cj, basic variable, so 10, 1, 2, 0, 0, x1, x2, x3, s1, s2. And here see, as I told you, s1 is leaving variable and x1 is entering variable. So in the iteration table 2, x1 is entering and s1 is leaving. For x1, what is the coefficient? Here coefficient is 10. And as I told you, this values, whatever the row values are there, which has to be divided by the pivot element. So pivot element is here, what is the pivot element? Is a 2. So 2 divided by 2, 1 divided by 2, minus 2 divided by 2, 1 divided by 2, 0 divided by 2, 10 divided by 2. So let us solve in the iteration table 2. So x1, 2 divided by 2 is 1, 1 divided by 2 is 0.5, minus 2 divided by 2 is minus 1, and 1 divided by 2 is 0.5, and 0 divided by 2 is 0, and the solution what we have 10, so 10 divided by 2 will be 5. 10 divided by 2 will be 5. Now S2, here, so S2, in the iteration table we were having these values. Now we have to find out new values for S2. So here this will be the same variable, but you will be getting the new values. So new values, how to calculate? See, there is a formula to calculate the new values. So simply, so new row 2. So what do we want? We want new row 2, that is this one. This is a old row 2 and this is a new row 2. So in the old row 2, see R2, that is R2 minus, see here what do we have? Pivot element 4. So R2 minus 4 into R1. R1 is a row 1, or you can take new row 1. So here this is the new row 1. So let me solve for you for better understanding. So now I have to find out the new value for this. So R2, row 2, the first value here, row 2 first value is how much? 4. So I am taking 4 minus 4 into new row 1. This is a new row 1 and this is a new row 2. So new row 1 is how much? 1. So 4 minus 4 will be 0, and I am taking that new value here. In the same way, here I have the value, second value, that is second column, old row 2, that is a 1. So 1 R2, that is 1 minus 4 is a key pivot point. So for all that row we are multiplying with the 4, that is the pivot element. 4 into, so new row 1 is having 0.5, that is equals to 1 minus 2 is equals to minus 1. So I am taking here minus 1. In the same way, you will be having the R2 1 minus 4 into, here then row 1 value is minus 1, 4 into minus 1 minus minus 4. So minus into minus plus, so that will be equal to 5. So next value we have 0 minus 4 into 0.5. So 0.5, that will be minus 2. In the same way, 1 minus 4 into 0 is equals to 1, and here if we observe in the solution column also, here what the old value is 20. So R2 will be 20 minus 4 into new row 1 is 5, 4 into 5, 20 minus 20, plus 20 minus 20 will be 0. So, okay, so 0, 0, minus 1, 5, and minus 2, 1, and here I will be having 0. Again, for this we will be calculating Zj. So 10 into 1 is 10 plus 0 into 0 is 0. So you will get 10 into 0.5, 10 into 0.5 you will get 5, and 10 into minus 1 is minus 10, and again here we will have 5 and 0. So 10 into 5 will be 50. So Cj minus Zj. So 10 minus 10 will be 0, and here 10 minus 10. Cj is 10, Zj is 10. So Cj minus Zj, 10 minus 10 will be 0, and 1 minus 5 minus 4, and 2 minus 10 will be minus 12, and 0 minus 5 will be minus 5 and 0. So still we have not only we got 2 values as zeros, and still 3 values are negative values. So will be, as we have not found the feasible solution, so again we will go further iteration. And before going for the further iteration, so the maximum negative is identified here in this particular column. So this I am marking it, and minimum, so 5 0, so the minimum value in this particular, and this will be the key element. The same procedure what we have done here for calculating new row, and for calculating the new row, the same procedure we have to repeat. Once again we will repeat the same procedure. So with the help of the iteration table 3. So here also I am taking the CBI, Cj, so basic variable 2 x1, 1 x2, 2 x3, 0 s1, 0 s2. So which is leaving here? So s2 is leaving, and which one will enter? The intersection, wherever the intersection is there, so that variable. So s2 leaves and x3 enters. So x1, and s2 is now leaving and x3 will enter. For x3 the variable is, quotient is 2. x1, in the iteration table, so s2 right. Now here s2 as the pivot element, intersection pivot element observed as 5, and this entire row has to be divided by 5. 0 divided by 5, minus 1 divided by 5, 5 divided by 5, minus 2 divided by 5, and 1 divided by 5, 0 divided by 5. Now the values will be new. So row 2 values will become, that is the x3, 0 divided by 5 will be 0, minus 1 divided by 5 will be minus 0.2, 5 divided by 5 will be 0, minus 2 divided by 5 will be 0.4 minus, and 1 divided by 5 will be 0.2, 0.2, and 0 divided by 5 will be 0. 0 divided by 5 will be 0. Now, new row, that is x1. So, new x1 values we have to find out. So, as I told you, so row 1, here I am taking row 1 minus pivot element. Here let me show you. Now for this row 1, that is x, for this row 1 we need to find the new values. To find the new values, here the key pivot key element in that particular row is minus 1. So we will be multiplying the entire row with the minus 1. So minus 1 into the row 2. So here the first value will be 1 minus 1 into 0, that will be 1, and here I am taking that value to 1. So new x1 value will become 1. In the same way, we have to find out for all the x1 values, row 1 values we have to find out. So second, what do we have? 0.5 minus 1 into minus 0.2. By simplifying you will get 0.3. Third, where first second, so first is done, so second is 0.3. Third value we have to find out. So minus 1 minus 1 into 1 will be 0. Fourth value, that is 0.5 minus 1 into minus 0.4, that is equals to 0.1, and 0 minus 1 into 0.2, that equals to 0.2. So 5 minus 1 into 0 is equals to 5. So now what we have, we got all the values, new row values. This is called new row values. Now what we have to find out? We have to find out, so we have to ensure all the values should be Cj minus Zj should be less than or equal to 0, then only we have reached the optimality. Up to that we have not reached the optimal solution, and we will be continuing this iteration procedure until we receive. In some cases optimality we cannot reach. So that means there is no optimal solution for that kind of problems. So Zj, we will calculate the Zj. So 10 into 1 is 10 plus 2 into 0 is 0. So we will get 10 into 0.3 plus 2 into minus 0.2. So careful here. So it will be 2.6. 2 into 10 into 0 is 0. 2 into 1 actually. 2 into 1. first, second, third. Okay, 5 by 5 is 1. So here 1, 10 into 1 is 2. So 10 into 0.1 plus 2 into minus 0.4. So becomes 0.2, and here we will get 2.4. 10 into 5 is 50. Now let us calculate Cj minus Zj. So Cj minus Zj, 10 minus 10 will be 0. 1 minus 2.6 is minus 1.6. 2 minus 2 is 0. 0 minus 0.2 is minus 0.2, and 0 minus 2.4 is minus 2.4. So here if we observe all the values Cj minus Zj values which are less than or equal to 0. So we can say that hence Cj minus Zj values are less than or equal to 0, hence optimality reached. Right. So this is how we will solve the problem using the simplex method, where we are adding the slack variables, and this is a example for minimization function. Thank you.